Hello and welcome to Dr. B.R. Ambedkar Open University, yet another scintillating lecture. So in this lecture, we are going to talk about the methods of correlation, which is the part of an MBA program, that is Hospital and Healthcare Management. In this lecture, we will be trying to include the correlation and regression, and which is part of block 2 and semester 1. So have you ever wondered, or did you see any difference or relationship between the child's IQ and also the parent's IQ? What about the degree of social trust that people have and the number of membership in the voluntary organizations? What about urban growth and air quality violations? Likewise, there are umpteen number of examples that we try to match and try to correlate different variables. Moving on, let us look at what is correlation. Correlation is nothing but it's the association between two variables. There are lots of examples and there are lots of uses and implications of correlation, particularly in research and also in health sciences and also in the medical sciences. Without correlation, I think the world would not be the same as you see it here. So in this session, we will try and include the correlation or understanding, significance of correlation, and uses, benefits of correlations, and different types of correlation. Let's get started with what is correlation. As the word says, correlation. Is there a relationship between two or more than two variables? And in statistics, we also called it as correlation coefficient. That is nothing but statistical index of the degree to which two variables are related or associated. And we can determine by looking at one variable and how this variable is related, interconnected, or associated to the other variable, whether they also vary with each other. When there is a relationship, we can also check how they co-vary. All these and many things that we are trying to learn in this session. So let us look at correlation. Correlation is a measure between two variables. Are they related to each other? If they are related, what is the strength of the relationship? So let us look at in various ways and forms through which correlation exists. First and the foremost thing is the positive correlation. And we will go into the depth of it while we talk about different types of correlation. But for our better understanding, let us look at positive correlation. Positive correlation, in the sense or in the strictly speaking sense, it is nothing but when two variable increases, both of them actually going to increase. One increases, other increases. That's a very simple way to put it out. And what about the negative correlation? In negative correlation, you see one increases or one variable increase will actually going to reduce the other variable and other variable decreases. There is also something called zero correlation. What is a zero correlation? We will understand it through example in our subsequent slides, but first let's understand zero correlation. Zero correlation is nothing but there is no relationship between two variables. So let's go into the deeper aspect of it by examples. Healthcare is an important area where correlations are being used. So the relationship between smoking and lung cancer. So a lot of people suffer with lung cancer, and one of the chief reasons for their suffering is smoking. So correlation helps us to understand the strength of the relationship, and by using the correlation matrix, doctors try to prevent lung cancer, and they would actually plan out how smoking can be able to quit and hence will give you an understanding of the lung cancer. So that's the relationship, you will be able to understand it. Now let us look at another example, same from the healthcare industry, that is age and blood pressure. Often it is told that older that you get, the blood pressure would increase. So there is a strong positive relationship between age and blood pressure. You can clearly see the relationship one variable increases, the other one also goes up. As the age progresses, the blood pressure would also go up. Let's move on and look at a few more examples, and this time we will try and look the negative, or the what we call the negative correlation. Take this example of cholesterol and exercises. So the more people exercise and they actually move from one place to other, the cholesterol levels will come back. That means there is a negative correlation between the two variables. The more that you put your body to use, the more that you exercise, the cholesterol levels will come down or gets reduced. Scatter plots are very important to understand because it gives you the visual representation. We will deal with them in our subsequent slides. So correlation is used largely in medical sciences and also in mental health care conditions. Like the other example, which is so vividly going to capture our attention, is the stress and sleep. The stress level and the sleep. The more you sleep, the stress level will come down. So there is a negative correlation between the two. And if you do not sleep more, and then the stress level will go up. So there is always going to be a negative relationship between the sleep and the stress level, because stress is going to put you into anxiety. Let us look at the strength of the relationship, because correlation also deals and talks about the strength of the relationship and the magnitude of the relationship. And usually it is indicated by the numerals. The numbers will indicate, and we'll look at in the Pearson R how this number is going to make a huge difference in our understanding and interpretation of it. So the strength of the relationship is often seen through linear relationship between and among the variables. Let's look at the graph. You have the small r equals to 1.0. That means it's complete, relationship that you can see it. It's 1. It's a positive relationship. And in the other graph that you can clearly see is that r equals to 0.24. Look at the dots on the straight line, how they are scattered. And if you come down and look at r equals to 0.85, these dots are not scattered so much, they are revolving. In fact, they are very closer to the straight line. And in the last example, that is on the right hand side, you can clearly see r equals to 0.17. In this case, the relationship looks to be very spurious. It's not really significant because the dots are scattered, they are quite away from the straight line. And we'll look at more example as we move along. But first, let us concentrate the idea of types of correlation. What are the different types of correlation? There are 4 different types. First and the foremost thing is the positive correlation. And we'll try and understand it through the example in our subsequent slides. And then comes the negative correlation. Then there is also zero correlation. And the last one is a perfect correlation. Apart from the types of correlation, you will also have the direction of the correlation, or the direction of the relationship, you can say it. So you can even understand the types of correlation through the direction of the relationship. Let us say how variables are positively or negatively related to each other. A value of one variable increases will actually going to increase the value of other variable. That is the direction or the positive correlation. The other one, which is quite contrary and opposite to the positive correlation, is the negative correlation. What is negative correlation? The value of one variable increases, the value of other variable decreases. So you can clearly see that through the example that we are going to have it. Look at this graph. Aren't they look totally opposite to each other? Look at those dotted lines. As the one variable increases, the top figure that you see, and the other variable also gets increases. So look at the x-axis and the y-axis. the same way that you can see the below graph. The below graph is totally opposite to that. If one variable increases, the other variable decreases. It would be better to understand it through the example. For positive correlation, let us look at height and weight. What is the relationship between weight and height? So in healthcare, we often see that blood pressure and age are also generally related. In the same way, height and weight. People whose height gets increased, their weight is also generally increased. So there is a positive relationship between weight and height. Let us take the example of the negative correlation. As we have been talking about cholesterol levels and the people who exercise, the more that people exercise, the cholesterol levels will come down. And that is the negative relationship. The more you do it, the more practice that you do it, the more exercises that you go and hit the gymnasium, then your cholesterol levels will come down. And this is a proven fact. So the doctors may look at the reports or the correlation matrix table and tell you that due to cholesterol or due to the exercises, your cholesterol levels are coming down. That is one. Now, what about the zero correlation? When you look at the zero correlation, that means there is no relationship that exists between variables. Look at this one. Shoe size and intelligence, how are they related? So, if people are wearing bigger shoe size, do you think that their intelligence will go up? Is there a relationship between people's shoe size and intelligence? No. Obviously, the answer is zero. So, in healthcare also, what is the relationship between blood type and IQ? What happens if someone has O positive, AB positive? Is there a relationship between blood type and IQ? There is no relationship. In fact, the relationship is zero. Then the fourth one is a perfect correlation. What do you mean by perfect correlation? Perfect correlation happens, look at the example, like temperature in Celsius and Fahrenheit. And in also healthcare, we often use dosage and the concentration in blood. So there is a perfect relationship. Although you are using different units, but the relationship is quite perfect. So these are the four different kinds and types of correlation that you see: positive, negative, zero, and perfect correlation. Let us look at this term, and often used in statistics textbooks. Even in your textbook it is mentioned. It's called correlation coefficient. And correlation coefficient can be best represented by Pearson correlation coefficient, often written with small r. You can see that in the brackets. So in the parenthesis that you have, the small r, when you get r equals to +1, that means it's a positive correlation. When you get r equals to -1, that is a perfect negative correlation. And when you get r equals to 0, it is a zero correlation. Do remember this small r, which plays a significant role in the statistics of correlation and methods of correlation. Let us now pay attention to the formula. As you know that statistics are full of formulae, and correlation is no different from it. In the correlation, we will try and solve it through computation. So the computation often happens through r. R equals to sigma, and then you open the bracket, that is x minus x bar, and here x is a variable and minus x bar, that means it's the mean of all the items of x. Then if you multiply that with y minus y bar, then divided by root of sigma into x minus x bar whole square into sigma y minus y bar whole square. So I want the learners to concentrate on the formula. So there are two variables. In this formula also you find x and y variables, and how they are correlated to each other will be determined through the formula. So do solve some of the problems using this formula. Are you ready to solve them? Let us look at by solving, or you can get the data, especially on the x-axis you have the exercise that you have done as per the number of hours per week. Let us say that I have exercised 20 hours per week. Then I plot the data on the x-axis. That is where my x variable is inserted with the data. And what about the y-axis? The y-axis is the cholesterol level. So with the exercise number of hours, the cholesterol level should come down. And that is also the example of the negative correlation that we have been talking a lot, isn't it? So it is very important that you interpret the example in the correct fashion and correct method. Now let us look at few more examples. On the x-axis, if you plot the age of the students, the age of the participants, and on the y-axis you have the blood pressure. So now you can calculate using the R formula that we had, and I have shown you, which is also present in your textbooks, that you can calculate the correlation coefficient of the two variables. The rise in the age will actually going to lead in the rise of the blood pressure. So there is a positive correlation. Isn't it that simple? Isn't it that easy? I hope that you're all learning. Let's move on and try to interpret. Let us say that your R gives you a value between 0 and 3. What are you going to term it? You're going to call this relationship a weak relationship. Are you not? And if you get R equals to, or R between 0.3 to 0.7, then you're going to say this relationship is moderate. And then what about if you get R equals to 0.7 to 1? Then the correlation is actually strong. And same goes if you apply the minus sign before these digits and numbers. That is for negative correlation. So correlation can also be understood through the visual representation, and in statistics we call it scatter plots. So scatter plots are nothing but visual representations of correlation, and it also shows a lot of patterns, and these patterns are quite helpful for anybody. Even a lay person can also understand and look at the pattern. The doctors pay a lot of attention to these patterns to understand it. So scatter plots are basically telling you graphically, visually, the relationship between two variables, and they can also portray the relationship between x and y variable, and they are represented through the x and y axis. So each subject, let us say I1 has x1 and y1, and when the scores are actually shown, the scores are going to be plotted for the entire sample or the population. The result will give you the scatter plot. Look at this scatter plot. Can you interpret this? Would you make sense of this scatter plot? What is there on the x-axis and what is there on the y-axis? Look at the dotted area. So these are the data points. And what about the straight line? How far or how close the dotted points are there near the straight line? You can easily make out, and that is the beauty of a scatter plot. These are some of the other examples of scatter diagrams, or we can call it scatter plots or scatter grams. Look at the first one, the positive correlation. You can clearly see one variable increases on the x-axis, the y-axis also gets increased, isn't it? And the totally opposite or diagonally opposite to it is the negative correlation. one variable on the x-axis increases and the y-axis variable gets decreased. And look at the last one to your extreme right hand side. There is hardly any relationship. All the dotted points, the data set is scattered. There is hardly any relationship between x-axis and the y-axis, or x variable and the y variable. So that's why it's important to look into it. So there is always, the age and blood pressure example that we give, and which is also the example of the positive correlation. The trend is moving upward, you can say it. Let us look at a few of the examples from the hospital. Since this is an MBA program in hospital and healthcare management, it makes sense for the learners to understand its different usages in various departments in the hospital, or medicine, or in the healthcare sciences. Let us look at how the doctors predict the patient outcomes. The doctors, looking at the graph or looking at the scatter diagrams, they will be able to make lots of interpretations, like what is the relationship between medical dosage with the recovery time. If you give, or the doctor might write, take this tablet or the pill thrice a day and the recovery would be fast. And if the same tablet is taken only once a day, the recovery might be slow. So that is the relationship between the dosage and the recovery time. And it would also help doctors to track not just the wellness of the patients, but also to know the hygienic condition and practices of the patients. So let us look at another example. This is also an important example because smoking and heart diseases. You must have seen on the cigarette packets, they say cigarette smoking is injurious to health. Why do they say so? They say so because studies have shown strong correlation between the smoking and the heart diseases. Heart diseases are basically coming from smoking. Your lifespan gets reduced, and that is the reason there is a strong correlation between smoking and the number of years you're going to get lost into it. And smoking and heart diseases are often used as a biggest example as far as healthcare industry is concerned to know about correlation. And it's used in a lot of other industries as well. Now let us look at the sleep and the stress level. The negative correlation exists between the two. Less sleep automatically leads to more stress levels. This is quite easy to understand. If you're suffering with insomnia, if you're not able to get a lot of sleep, or at least 5 to 7 hours of sleep, then you are certainly going to have stress levels, and the stress levels would go up. Same is the case with exercises and diabetes. The more you exercise, the diabetes would get reduced, and that's an easy way to understand it. One of the other things that many students and participants have a doubt about, what is the relationship between correlation and causation? Are they the same? Are they going to represent the same thing? So let me tell you that it's not the same thing. Correlation and causation are two different things. They are absolutely different in many ways. Let us look at how are they different. One and the foremost thing is that, let us look at this example. If you consume ice cream, or if ice cream sales and sunburns are correlated, yes, they are indeed, but they are not the causality. There is no causation and effect relationship. They are related, they are interrelated, they are correlated, but one is not leading to the other. If there is an increase in the sales of the ice cream, are there sunburns? You have to look into the data. I think this example makes it very clear about the understanding of correlation and causation. There is also another thing when we talk about correlation, and this is called the Spearman rank correlation. The Spearman rank correlation is nothing but it's often used for non-parametric methods. When you have non-parametric statistical tool, you are straight away going to use a formula for Spearman's rank correlation. So what does that mean? So usually the data is not normally distributed. So if you plot the data, when the data is not normally distributed, you are going to use the Spearman's rank correlation, like patients rank in recovery speed. And that is why we are going to use not the Pearson correlation, but this time we are going to use the Spearman rank correlation. Remember the difference between the two for parametric and non-parametric. For non-parametric, we are using Spearman's rank correlation. As the word says, ranking the patient according to the recovery time. And that's why it's important to look into it. There is also another concept called the partial correlation. What is a partial correlation? The partial correlation actually measures correlation between two variables while controlling the other one, like diet and cholesterol, controlling for age. Often doctors wanted to control. So this is also the control variable in some sense. There is a direct relationship between diet and cholesterol, but if you don't really take into account the age of it, then you may get spurious results. There are umpteen number of applications in the research, and especially in the medical research. Like in clinical trials, you use a lot of correlation matrix. You also use in the pharmaceuticals, especially with the drugs, and you are going to test the effectiveness of the drugs with the diseases. The other one is also when you have the public health survey. So we will look at quickly some of the examples and cases like blood sugar and insulin. So there is a strong negative correlation between blood sugar and insulin. If you take insulin regularly, then your blood sugar will come down, isn't it? Weight and blood pressure, we have spoken about it. Then in the mental health sciences, we have a lot of understanding about the stress level and the patient performance. There is also a lot of correlation studies are being used in radiology, like for example, size of the tumor versus the stage of the cancer. Will they be able to determine through correlations? And the answer is yes. And it is an important way to diagnose the stages of the cancer. Then, apart from that, in the children's healthcare, like pediatrics, correlations are also being used quite often, like vaccination coverage to the disease outbreaks. Height and age growth charts will also give you the understanding. What is the age of the child and what is the height of the child? You can easily make out. And then in cardiology also, correlations are being used, like exercise versus the health of the heart, and cholesterol and the heart disease risk. There are many advantages of correlation. Few of the advantages, like they're very simple to use, and you can also, looking at the scatter plot, interpret the results, and it will also going to help you to take decisions. Doctors are able to take the decision based on correlation. But apart from the advantages, we do have some disadvantages, because correlation does not mean causation. That's the first disadvantage. The other one, if there are some outliers, then it might be sensitive to those outliers. And the last one is that it only supports the relationship. So please do remember that you are going to increase or make some of the mistakes or common misinterpretation through that very important thing called ignoring the confounding variables. So as a student, you should be able to collect the data step by step, compute the data and compute the means through right formulae, and also able to interpret it. You can do lots of activities, there are many questions, and there are lots of things. So We have learned so far that correlation means relationship between variables. Let us summarize them, and it helps the doctors and the healthcare workers to understand the patterns so that they can take the decision based on the interpretation. I hope that you have learned a lot from this methods of correlation, and this is what we have for you. So please feel free to raise the questions in our chat box or comment section, and we look forward to your company again. Until then, it's goodbye from all of us from the studios of Dr. B.R. Ambedkar Open University. See you soon.